Hey guys, um, back at it for another video from home. One of your peers had a question from lesson 2.4 on question number 36. So I wanted to take a look at it and share that with you. It's a really good question, a great question in fact. So let's take a look at it. Alright, so the question says, find the equations of all lines tangent to y equals 9 minus x squared that pass through the point 1, 12. Okay, so find the equations of all lines that are tangent to y equals 9 minus x squared that pass through the point 1, 12. Okay, so first off, hopefully what comes to mind a little bit is, let me zoom out a smidge. Is a graph of this. We're dealing with the graph of y equals 9 minus x squared, and we're looking for equations of lines that are tangent to this curve and also go through the point 1, 12. So first off, let's do a decent sketch of what y equals 9 minus x squared looks like. This is a parabola that opens down that's been shifted up 9 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's going to be its vertex, and you can tell that when x is 3 or negative 3, we have zeros of that function. And so we know this is a parabola that looks like so. So then we also have this point 1, 12. 1, 9, 10, 11, 12. So you got this point up here. So hopefully you'd agree that there's maybe some tangent line, I don't know, over here-ish. Maybe a tangent line, I don't know, somewhere over here-ish. Not the greatest picture, but you can see how we might run into two tangent lines that are tangent to the curve and passing through this point 1, 12. Okay, and again, I know my picture is not great. So, all right, well, what we need is, if we're going to write the equations of these lines, we've got to be thinking about slope. Okay, so we need to think about slope really in two different ways. We want to think about slope as in slope of any point on this, the slope of any point on this curve with this point. Okay, so we're going to call any point on that curve x comma y, but more specifically, we know that y is 9 minus x squared. So we can think of this as x comma 9 minus x squared. So there's one point. Now there's also the point 112, and we can calculate that slope. Okay, so we know that that slope would be, let's do 9 minus x squared minus 12 all over x minus 1. So that slope, which can be simplified as what? Negative 3 minus x squared all over x minus 1. But that's not the only way that we can calculate slope. Remember that an instantaneous rate of change is a slope at any point on the curve. So let's find the instantaneous rate of change, and that should always be equal to this. Okay, so, or at least we're interested in the instances where it's equal to this, I should say. Not always. It definitely won't always be. Okay, so let's think of this from an instantaneous rate of change perspective. And in order to do that, we're finding the limit as h approaches 0 of what? Let's see here. We want to consider f of x plus h minus f of x all over h, right? So specifically, f of x plus h, well, that's, hold on, the limit is h approaches 0. Can't be lazy with my limit notation. 9 minus x plus h quantity squared, that's what f of x plus h would be, okay, minus f of x, which is 9 minus x squared, all over h. Okay, so time to do some simplifying here. Equals the limit as h approaches 0 of, we got to expand a binomial and then distribute a negative, so this would be 9 minus x squared minus 2xh minus h squared. Now I'm going to distribute that negative, minus 9 plus x squared all over h. Okay, keep simplifying with what cancels. 9 and a negative 9, a negative x squared and a positive x squared. The two terms left over are all divisible by h. So I'm going to go ahead and cancel the h out of each of those. So you have negative 2x minus h. Well, what is the limit as h approaches 0 of that expression? That would just be negative 2x. Okay, so what did we learn here? What we learned was that the slope, let's go back to the picture. We learned that the slope anywhere, back to the picture, sorry. We learned that the slope here is negative 2 times x. So in that situation, x is negative 3. So my slope there is negative 6. Sorry, no, wouldn't it be positive 6? Because negative 2 times negative 3, so negative 2x. So if my x right here is negative 3, then I know that my slope is negative 2 times negative 3, or 6. But as I get closer and say I'm at negative 2, at negative 2, my slope would be now positive 4, right? It's less steep, okay, to the point where I get here to 0, and my slope is 0, yep. Okay, so realize that this is the, down here, negative 2x, that's the slope of the tangent line everywhere. Well, I want to know, where does that slope equal specifically this slope, because this is the slope of any point on my curve with 112. Okay, so this is the part that tells me, though, it's tangent, right? And so I want to know, when is my tangent slope equal to the slope anywhere from any point to the point 112? Okay, so I'm going to go ahead now and set each of those equal. So negative 2x, where is that equal to negative 3 minus x squared over x minus 1? We can solve this equation relatively easily. So we're going to go ahead and get rid of this denominator by multiplying both sides by x minus 1. And I'll go ahead and distribute at the same time. You should end up with negative 2x squared plus 2x equal to negative 3 minus x squared. All right, so let's finish solving. This looks like this is a quadratic. I'm going to go ahead, so that my leading coefficient in standard form is positive, I'm going to go ahead and bring all this stuff over to the right side. So you end up getting, I think it ends up being a x squared minus 2x minus 3 equals 0. That looks like a really nice quadratic. Let's factor that sucker. 0 equals x minus 3 times x plus 1, right? And then what does this tell us? That x equals 3 or negative 1. So what did I learn? I learned that where my instantaneous rate of change, my slope of my tangent line to the curve, is equal to the slope of any point to the point 112. So that would include, you know, what I found here. That was this, the slope here, the slope here, the slope here. But the only instance where these two are equal is at the tangent line. This wouldn't be a tangent line up there, okay? So I've got 2 points, when x is 3 and when x is negative 1. Okay, so at each of those, I need to solve for what is the equation of the tangent line. Well, in order to write an equation of a line, back to your Algebra 1 days, okay, we need a point and a slope, or 2 points, right? Well, we know 1 point, 112. What's these other points? So when x equals 3, we really have the ordered pair 3 what? 3, 0. Okay? Right there is 3, 0. Or plug in 3 for x and you get y equals 0. So we've got that point, and again, 112 making up the tangent line. And then we also have when x equals -1, that is what point? Well, let's plug in -1. Square -1, you get 1. 9 minus 1 is 8, so that should be -1, 8. -1, 8 seems legit. Okay, and then and the point 112 in order to write the equation of the line. So with both of those, I need to take a slope and a point in point slope form. Let's go ahead and do slope. M equals what? 12 over -2. 12 over -2, so -6. And if your slope is -6 from a point 112, then that means you're going down through 112, so over 1 up 6, so you should end up with a y-intercept of 18, I believe. So we get y equals -6x plus 18. Decided not to go point slope form. It decided to just think about it because of how close this point is to the y-intercept. Okay, so that's the equation of the tangent line through this point 3, 0 on the curve and through that point 112. Lastly, do it one more time. Slope here, changing my y's is 4, changing my x's is 2, so I think we get a slope of 2, and a slope of 2, which is a positive slope through the point 112. Then I actually am going down left, so I think we get b to equal 10, if I'm not mistaken. So we get y equals 2x plus 10 for the equation of the other, oops, sorry, it was off the screen. This equation of the other tangent line to the curve that passes through the point 112. Okay, so those are the two solutions to this question. I'll double check that I didn't make a mistake. And I did not, so that's good. But once again, big idea. What were we doing? We could calculate slope kind of in two different ways. The slope between any point in the point 112, but the bummer is I'm not just limited there, because if I did this point, let's say right here in the point 112, that's not a tangent line, right? So, but it does tell me what the slope would be. But then when I did this work on the instantaneous rate of change, this is telling me my slope everywhere along this curve, the slope of the tangent line. So I want to know, when is the slope of that tangent line equal to the slope from any point through that point 112, okay? And so that's why I set those two equal. And we went ahead and solved that equation that ended up being a quadratic equation to tell us those 2 points. And lo and behold, if we go back to our original graph, Mr. Breen did a decent job here at -1 and what was that point? -1, 8 right here. That's kind of looking like where that tangent line is, and then at 3, 0 right down here where that other tangent line ends up being. So hopefully that helps. Once again, as I said in the past, thanks for asking that question. Feel free, if you have other questions, to shoot them my direction. I'll do my best to help from home and get these videos out to you. Stay safe, and we'll catch you when I return, or catch you on another video later. Take care, guys.